Welcome back to the Deep Dive. Today, we are jumping right into what is, I think, the fastest moving, maybe the most chaotic sector in all of software development.
It has to be. We're talking about AI-powered coding, or as everyone seems to be calling it now, vibe coding.
Vibe coding is a term that sounds a little playful, maybe, but the shift it describes is anything but.
It's massive, and we've got a whole stack of sources in front of us, developer notes, articles, some pretty heated community discussions that really cover the entire landscape, from these new autonomous coding agents all the way to the very tricky economics of actually using them.
Right. So our mission for this deep dive is to try and draw a map of the 2025 landscape. We want to separate the hype from what's actually happening on the ground.
And give you, the listener, a clear sense of the trade-offs.
Exactly. And we should probably start with the new metric, the new speed test, really.
Mm-hmm.
For years, the benchmark was what? Raw code speed, security.
Sure, things like that. But now, the single most critical benchmark in development is the time it takes to get from an idea, that proverbial napkin sketch, to a live deployed product.
That's the new currency then, the speed of intent.
It's absolutely the currency. And that's where the term vibe coding actually becomes pretty insightful. It's not about typing syntax anymore. It's about conveying a vibe, a sort of high-level goal, or even an emotional intent to an AI.
And you expect a full product back.
You expect a full product back. You're coding with your intent, your feelings, not just your fingers.
It really does feel like we're getting closer to just turning thought directly into code.
We are. And what's so fascinating is that if you look at the history, this is kind of where computing was always supposed to end up.
What do you mean?
Well, we've spent, 50 years in the era of the graphical user interface? The mouse, the keyboard, what they call the direct manipulation paradigm. But the original vision, if you go way back to people like Alan Turing...
Right, they weren't thinking about clicking menus.
No, not at all. The pioneers, people like John McCarthy and Marvin Minsky, back at that Dartmouth workshop in '55, they framed the whole concept of AI around reasoning, around autonomous agents that could respond dynamically to human goals. So AI coding, in a way, isn't some new utility. It's the original promise of computing finally being delivered.
So we're moving from managing machines to collaborating with them, with these reasoning partners.
Exactly.
Okay, so that idea of autonomy, that's the perfect place to start. Today we're going to tackle this in three main areas. First, that huge leap from simple assistants to agents that truly own a task.
Right. The difference between autocomplete and an actual collaborator.
Second, the ecosystem wars.
Yeah.
The big platforms, Lovable, Bolt.new, V0, and how they're all fighting for their space.
And finally, the part that's causing so much friction for indie developers, the surprising and often pretty painful economics of paying for all this AI reasoning.
That economic part is something we absolutely have to dig into.
We do, because it's turning out to be the real bottleneck in 2025. It's not about technical capability anymore. It's all about cost and predictability.
Okay, let's get into it. Part 1, the autonomous revelation.
From autocomplete to task ownership.
So let's define that in really...
Because a developer in a state of flow can solve problems orders of magnitude faster. It's that state of total immersion. But modern development is it's a minefield of interruptions. Slack, emails, meetings, it breaks that focus.
So the goal of these new agents is to take on the whole task, end to end, and let the human focus on the bigger picture.
Exactly, to protect and grant back that engineer's cognitive flow.
Okay, this is where it gets really interesting. Let's talk about Replit Agent 3. The sources are pointing to this as the core achievement for Replit in 2025.
It's a huge step. They've moved from an assistant, inline suggestions, to what they call a project-level autonomous collaborator.
What does that mean in practice?
It means they've introduced this max autonomy mode. It's still in beta, but it lets the agent operate completely unsupervised for up to 200 minutes.
200 minutes.
200 minutes, continuously. Just think about that. That's over 3 hours. It's enough time for an agent to tackle an entire development task like building out a whole authentication system and a database schema without a single human check-in.
That's a game changer for speed.
Right.
But my first thought is, if it's alone for 3 hours, who's checking its work? I'm just imagining it coding away and then committing some catastrophic bug right at the end.
And that is precisely the anxiety they had to solve for. This brings us to its most important feature, self-healing code.
Self-healing code.
Yeah, I mean, generating code is the easy part. Generating working code is hard. So Replit built this proprietary automated testing system to get around that classic AI problem where the model makes a logical error that you just can't see by looking at the
So
text.
how does it actually work?
Well, the agent dynamically decides when a test is needed, and this is the key part. It spins up an actual browser instance to interact with the app it's building.
So it's not just running a theoretical test, it's acting like a user.
Exactly. It's
Ugh.
performing its own QA check, it clicks buttons, it submits forms, it tries to log in, it's identifying bugs that only show up at runtime.
Okay. And if it finds one?
It enters what they call a reflection loop. It automatically tries to fix the bug, integrates the fix, and then reruns the test over and over until the functionality is actually verified.
Wow.
And the sources claim this whole system is 3 times faster and 10 times more cost-effective than trying to use a generic AI model for that same QA process.
That really does shift the idea of AI coding. It's not just generating text anymore, it's about shipping working features.
Hmm.
But I have to ask, what happens in minute 190 if the AI just fails? Does the human just get a bill for 3 hours of failed thinking?
That's the multi-hundred-dollar question, isn't it? And it gets to the heart of autonomy and liability, which we'll definitely hit in the economics section. When you give an AI 200 minutes of runway, you're shifting the responsibility for verification onto the machine. If it fails, the cost isn't just compute time, it's the human time wasted trying to figure out what went wrong.
So that self-healing part isn't just a feature, it's an economic necessity. It has to absorb the cost of its own mistakes.
It has to. That is true task ownership.
Okay, so that's Replit's approach. Now let's pivot to Verdent AI. They seem to be tackling the speed problem from a totally different angle. They're focused on parallel execution.
Verdant's philosophy is fascinating. Replit is trying to build one super competent autonomous engineer. Verdant is basically saying, why have one smart engineer when you can have an entire micro team of specialists working at the same time?
That sounds chaotic. My first thought is just a mess of conflicting code changes. Is that 10 times faster claim? Just, marketing fluff?
It's a great question, and that 10x number isn't about raw coding speed. It's about eliminating waiting time and context switching.
Okay, explain that.
If a human developer has 8 subtasks to do, they have to do them one after the other, sequentially. Verdant deploys multiple autonomous agents in parallel, each one tackling a different task. So this orchestrated micro team just crushes the total clock time needed for a complex project.
So the value is in doing things simultaneously. But still, how do you keep 8 different agents from stepping all over each other's code?
That's the smart part of their platform. It's all managed by their desktop environment, the Verdant Deck. It runs each agent in a completely isolated environment. They call them work trees.
So it's like an automated, secure version control branch for each task.
Precisely. A sandbox for each agent. So a developer can try out different approaches in parallel. Maybe Agent 3's idea for the auth routes was great, but Agent 6's database refactor was cleaner. You can compare the results and then just merge the best bits into your main branch. No conflicts.
Do we have a concrete example of this?
We do. The sources pointed to a user who needed to refactor a big, complex API. They just prompted Verdant to, refactor this API to use async await and add proper error handling.
Yeah.
And the agent didn't just start coding. First, it made a plan. It broke the job into 8 smaller subtasks, each one for a different route: file user creation, login, item retrieval, and so on.
Then it launched the micro team.
Exactly. 8 separate agents, all running concurrently in their own isolated work trees. A task that would have taken a human days of tedious sequential work was done in a fraction of the time. The developer just had to review 8 clean, isolated pull requests at the end.
And this kind of framework, I imagine, also lets you be smarter about costs.
Absolutely. Not every task needs the most powerful brain, right? Verdant lets you configure different language models for different tasks. You can use a powerful, expensive model like GPT-4 Opus for the complex architectural thinking, but then use a cheap, fast model like Haiku for just generating boilerplate.
That seems critical for managing the budget.
It's a huge step forward for keeping agent usage efficient and affordable. Tiering your models based on the cognitive load of the task is going to be essential.
Okay, so we've got these incredibly powerful new agents. But now we have to talk about the battle for where they live, the IDE itself. The war isn't just about who has the smartest AI, it's about who owns the developer screen all day.
And this has always been Replit's ace in the hole. Its core identity is that it's a full-stack platform and a cloud IDE with zero setup. You click a button and you have hosting, 50-plus languages, a database, auth services. Everything, instantly, in your browser.
And that speed is its real competitive edge. The
Mhm.
sources brought up a great example with a tool called Siraj.
Yeah, the Siraj example is perfect. It's an Arabic language AI learning assistant for students in Jordan aligned with their curriculum. I mean, building a huge custom project like that would normally take a ton of time just for infrastructure setup.
And with Replit,
The developer was able to leverage that pre-integrated environment to prototype, test, and deploy the entire thing in a fraction of the time. They basically bypassed all the tedious setup, the server provisioning, the configuration. It's Replit's signature move, especially for MVPs that need to be live, yesterday.
that's great for startups. But what about the enterprise? Are the big cloud players fighting for this vibe coding market, or are they sticking to their guns?
Oh, they are absolutely in the fight. Replit itself is expanding its partnership with Google Cloud specifically to bring these capabilities to enterprise teams.
So they're using Google's models.
They're using Google's Gemini models through Vertex AI. It helps meet all the enterprise data governance rules, and they're integrating the latest Gemini 3 models right into Replit's design mode. It's a serious move to take AI coding out of the indie hacker space and into a scalable corporate workflow.
And of course, you can't talk about the cloud without talking about AWS.
Never. And AWS Cloud 9 is still a huge contender. Its strength is just that undeniable deep integration with the whole AWS ecosystem. If your company is already all in on Amazon, Cloud 9 is the path of least resistance. Your environment is pre-configured, you can deploy to EC2 or Lambda in seconds. It's seamless for cloud-native projects.
But what about the professional developer? The one who loves their powerful desktop IDE but wants cloud flexibility.
That's JetBrains territory. JetBrains space dev environments. I mean, for a lot of pros, tools like IntelliJ and PyCharm are the gold standard. Space brings that familiar, powerful experience into the cloud. You can run a full JetBrains workspace in your browser or connect to it remotely.
There are trade-offs though, right? I've heard it's pretty heavy.
There are. It's really best for existing JetBrains users, for one. And yeah, our sources note it's known for being heavy on system resources, which means higher underlying cloud costs. It's professional-grade power, but you definitely pay for it.
So we have the IDE war. Now let's drill down into the assistants themselves. There's this huge split happening between the closed source SaaS tools and the open source alternatives.
And this trade-off is central for any enterprise trying to adopt these tools. On one side, you have the closed-source players like GitHub Copilot and Tab9.
Copilot being the big one.
It's the ecosystem leader, for sure. It uses OpenAI's best models. The suggestions are top quality. But the trade-off is clear. You pay a subscription, and you have to send your proprietary code to Microsoft and OpenAI's cloud to get a result.
Which for a bank or a government contractor is a complete non-starter.
Exactly. They are deeply, deeply wary of their code leaving their secure environment. And that's where Tab9 has found its niche. They're positioning themselves as the privacy-focused alternative.
So their whole selling point is that they don't see your code.
Right. Strict zero data retention policies. It learns from your team's proprietary code base in-house to provide suggestions, all while ensuring your internal coding standards are being followed. It's the privacy-first choice.
And this sets the stage perfectly for the open source movement, which seems to be gaining a lot of momentum. Tell us about this tool, CliClient or Row.
Yeah. Colliding, also known as Roo. It's an open-source autonomous assistant for VS Code, and it tackles the privacy and cost problems head-on. It has this really interesting dual plan and act mode. So it devises a detailed, auditable plan first, and only then does it execute the changes.
And the big economic benefit here is what? Control.
Total control. The user connects their own API keys. You can use GPT-4, or you can use a model you're running locally with a tool like Llama. This means your code never has to leave your desktop.
And you're not paying a vendor's markup on the AI compute.
Exactly. You only pay the raw model usage cost. For enterprise leaders looking at this, the takeaway is clear. If you're worried about vendor lock-in, data privacy, or just predictable costs, the open source bring your own key route is becoming incredibly powerful.
Okay, that brings us right to the heart of vibe coding, the prompt to app builders. These are the tools that are really democratizing software, letting non-technical people build real prototypes just by describing an idea.
This landscape is so competitive and very segmented. If you pick the wrong tool for your goal, you can end up really frustrated and waste a lot of money.
So let's break it down. Let's start with Lovable.dev. This
Yeah.
seems to be the most full-stack solution aimed at that non-developer founder.
That's exactly who it's for. Lovable is optimized for the entrepreneur. It's for rapid prototyping for full-stack MVPs. We saw users citing 12-minute MVP builds.
Is that real? A 12-minute MVP?
I mean, it's not hyperbole. It refers to how fast it can generate a functional hosted application that's ready for users to test.
And the key to that is its backend integration, right?
Absolutely critical. Lovable has this deep, seamless integration with Supabase, which they call Lovable Cloud. So the app it generates comes with a fully managed backend, a PostgreSQL database, file storage, user auth, serverless functions, all of it.
So if I say I need an app where users sign up and save data, I don't have to go configure a database.
Nope. You just prompt, I need an app where users can sign up with email and save a list of their favorite books, and Lovable generates the UI, the sign-up flow, the database tables, the whole thing. The recipe generator example was perfect. It needed custom backend logic to analyze images from a phone, all generated from a prompt.
And they did something really smart about the cost of design changes.
They did. This is brilliant. It has a visual editor for layouts and content, but visual edits do not consume credits.
Oh, that's huge.
It's huge. It means a product manager or a designer can go in and tweak colors, change text, move things around for free.
Right.
You only burn the expensive AI credits when you're generating new features or complex logic, not for just moving pixels.
Okay, now let's contrast that with Bolt.new. This one feels like it's built for developers who want more control.
Bolt is definitely for code-first workflows. It's less magic button and more AI-supercharged IDE. It supports a broader range of frameworks, React, Vue, Next.js, Svelte, and it gives you full access to the underlying environment, terminal, and all. It's the professional developer's vibe coding tool.
And its killer feature, this diff-based editing, seems to speak directly to the cost problem we're going to talk about.
It's their signature innovation. They introduced it to fight two things: token costs and AI hallucinations. If a human changes one variable name, a standard AI agent might just rewrite the entire 500-line file to be safe.
Which costs a fortune in tokens.
A fortune. Bolt, instead, forces the AI to only generate the specific minimal change needed, the diff. It drastically cuts token use, saves time, and makes the change much easier for a human to review.
And Bolt seems much more portable than something like Lovable.
It is. It's all built on the standard Vite and NPM ecosystem, so you can export your project as a zip file or sync it to GitHub and host it anywhere, Netlify, Vercel, wherever. You are not locked into their platform. Plus, they have Bolt.diy, an open source version you can run locally, which is a huge deal for security-conscious teams.
Okay, moving on to V0 by Vercel. This one seems much more focused. A specialist tool.
Vercel V0 is the component specialist, and it is crucial to understand that limitation. It is not a prompt-to-app tool. It's for generating high-quality UI components for existing projects, especially if you're in the Vercel ecosystem.
So it's great for quickly building out a front end.
Fantastic for it. You can give it a text prompt or even import a Figma design, and it spits out production-ready React components styled with Tailwind CSS.
But if I'm a founder trying to build a whole app, V0 is the wrong choice.
Completely the wrong choice. And this is the big limitation. No built-in backend. You can ask it for a beautiful login form, and you'll get one. But you have to write all the code yourself to make that form actually do anything. It's a tool for developers and designers, not a full-stack platform.
And let's quickly touch on the dark horse, Rocket.new.
Rocket.new saw one massive gap in the market: mobile apps. Most of these tools are web-only. Rocket.new can create full-stack applications, including mobile-ready apps built using Flutter.
So from a single prompt, I can get something for iOS and Android?
That's the promise. It's mostly used for internal tools, analytics, dashboards, and things like that. But they raised $15 million, so investors clearly believe in that mobile niche.
Okay, so let's summarize this ecosystem.
Sure. If you need beautiful UI components for an existing project, you use V0. If you're a non-technical founder who needs a fully hosted, full-stack MVP in 15 minutes, Lovable is your best bet because of that deep Supabase integration.
And if you're a professional developer who wants flexibility, control, and portability,
you're looking at Bolt.new or its open source version for that iterative workflow.
Okay, we've talked about all this amazing technical power, but now we have to get to the harsh reality of paying for it. This brings us to the world of effort-based pricing.
And this is where so many indie developers are running into a brick wall. The problem is that the cost of AI coding is tied directly to the complexity, the effort the model has to use.
Right, so the big reasoning models, Opus, Agent 3, are just inherently way more expensive to run.
Much more. And this confuses people. They'll ask, why did this request cost so much? The code it produced was only a few lines long.
But you're not paying for the typing.
You're not paying for the typing, you're paying for the thinking. It's like hiring a lawyer. You pay for the hours of research, not just the time it took to type the final brief. These models are running internal chains of thought. They're self-checking. They're looking at your entire code base for context, and you get billed for all of that compute, even if the final output is tiny.
So a powerful model might cost 10 times more to generate the exact same function as a cheaper one, just because it spent 10 times longer thinking about it.
Exactly. And this leads us right to the sticker shock people got when Replit introduced effort-based pricing. Simple tasks can be as cheap as 6 cents, but it scales up really fast.
The user reports in our sources were pretty shocking.
They are. Replit's core plan is $20 a month, and it comes with $25 in AI credits. According to multiple users, if you use the max autonomy mode for any serious work, you can burn through that entire $25 credit in just 1 to 3 hours.
1 to 3 hours for a whole month's budget?
Yeah.
That's completely unsustainable for a hobbyist or a bootstrapper.
It creates massive financial anxiety. We saw that case of the longtime user trying to fix problems in their legacy app. They used the autonomous agents to tackle the messy code and ended up with a bill for $370 in 1 month.
$370. That just completely undermines the whole appeal for an indie dev.
It does. And the biggest risk is that if the agent gets stuck in a logic loop, or if it has to retry a bunch of times, you're just burning through credits without getting any results. One user described how the AI, trying to fix a bug, decided to change the core matching logic of their dating app by its own desire, creating this huge, expensive mess.
So autonomy requires intense financial discipline from the human. But Replit's not the only one causing this friction. Lovable has its own issue, what users have started calling the bug tax.
The bug tax. This is a huge point of frustration in the community because it feels like a double penalty.
Explain what it is.
Okay, so you pay credits for the AI to generate some code. The AI generates code that has a bug in it, which happens a lot. Then you have to spend more credits to ask the AI to fix the very mistake it just created.
So I pay for the creation, and then I have to pay again to fix the creation's failure. That feels wrong.
It feels incredibly unfair to the user. From Lovable's perspective, fixing the bug is a new, complex reasoning task that uses up more compute power, so they charge for it. But from the user's perspective, it feels like a warranty repair that should be free. It's a huge emotional friction point that just erodes trust in the AI's quality.
So with all this unpredictability, are people flocking back to simple, fixed subscription models?
For a lot of teams, yes, predictability is gold. A tool like Cursor, for example, has a simple pro plan for $20 a month. You know exactly what you're getting, whether the AI has a good day or a bad day.
But the trend seems to be heading towards a hybrid model.
It is. A blend of a fixed monthly fee, like Replit's base charge, with pay-as-you-go for the really heavy-duty autonomous tasks. But it forces developers to act like financial analysts. You have to monitor your usage constantly and budget for those unexpected spikes. You just can't be cavalier with max autonomy mode.
Okay, we've talked a lot about the speed and the power, but now we have to get into hard limitations. Because speed is meaningless if the code is fragile, or worse, insecure. What's the reality of the code quality we're seeing?
The consensus is universal. Human oversight is not optional. It is absolutely mandatory. AI-generated code still suffers from really predictable flaws.
Yeah.
We see over-engineering, the AI using 5 files for something that should be 1. We see inconsistent patterns where it just ignores the team's style guide. And we see tons of missed optimization opportunities.
And the security risks are not just theoretical, are they?
They are deeply concerning. The rush to generate code is outpacing the rush to verify it. Our sources point to a worrying trend. Using these tools can lead to a measurable increase in vulnerabilities. One report said over 20% of users saw more security issues, and another suggested up to a 41% increase in bugs when using a tool like Copilot.
Wait, 41% more bugs? That's astonishing. Is that a flaw in the AI or a flaw in how humans are using it?
It seems to be a flaw in the workflow. The AI generates code so fast that the human tendency is to just accept it and move on. You skip the rigorous code review you'd do if you wrote it yourself, so you're basically just accelerating the creation of technical and security debt.
And that leads right to what you've called the founder's dilemma, the non-technical founder who was promised they could build a startup with a prompt.
It's the recurring nightmare scenario. These tools are amazing at getting you from 0 to, say, 80% of a working prototype, but when things get complicated, they hit a wall. The Stripe integration fails, or some weird bug pops up in a Lovable edge function, and the non-technical founder is completely stuck.
So the AI gets them 80% of the way there for almost nothing. But fixing that last 20% costs a fortune.
It's the most expensive 20% you will ever pay for. You're left with this huge stack of code you don't understand, and you have to go hire an expensive senior engineer just to unravel the mess the AI made. It perfectly illustrates that warning we found. A prototype that can't coexist with your code base isn't a shortcut, it's another silo.
Okay, so for professionals listening, what are the actionable strategies here? How do you use this power without falling into the traps of cost and debt?
We pulled out 4 key strategies from the sources, and it all boils down to maximizing clarity, not being clever when you talk to these agents.
First up, define and ground the AI.
This is foundational. You have to anchor the AI in your team's existing components, your design tokens, your code-based conventions, what developers call the team's rails. If the tool can't learn how you already build things, its output is going to be unusable.
Strategy 2, focus on mergeability, small changes.
Exactly. Choose tools and workflows that produce small, transparent changes a human can actually review. Bolt's diff-based editing is the perfect example. You have to avoid those flashy demos that generate thousands of lines of code at once, because if you can't review it, you can't merge it.
Strategy 3, model tiering. Match the model to the task.
This is crucial for controlling costs. Use the cheap model, like Haiku, for quick UI sketches. Use a balanced model, like Sonnet, for medium complexity features. And only use the most expensive, powerful model, Opus, for the really critical production quality logic. Don't use a supercomputer to write an HTML button.
And finally, what do you do when the AI messes up? Avoid the rabbit hole.
Right. When you hit in mirror, don't just keep hitting the autofix button. That's how you burn credits. Instead, switch to a discussion mode. Ask the AI specific questions about the error, formulate a manual plan, and do some research before you ask it to try another fix. That human pause saves a ton of money.
So looking ahead, just quickly, where are these agents going in 2026?
2 big trends. First, much better tool use. Right now, they can run a shell command. In the future, they'll integrate seamlessly with everything: APIs, databases, CI/CD pipelines. That has to happen for true task ownership.
And second, the end of the general purpose model for coding.
For product development, I think so. Domain-specific models that are continuously trained on in-product data user behavior, successful merges, bug reports, they're going to surpass the general models in both performance and cost. The platforms that own the execution data, like Replit or Verdent, have an insurmountable advantage there.
So after all that, what does this mean for you, the learner, trying to navigate this landscape in 2025?
I think the key takeaway is that we've made this monumental leap to autonomy, but that autonomy is tied directly to the cost of effort or reasoning. So that economic model, effort-based pricing, becomes your #1 concern. You have to be aware of the cost of every thought the agent has.
And remember, the tool choice is totally mission-dependent. V0 is for components. Lovable is for the full-stack no-code MVP. And platforms like Replit and Bolt are for that flexible, code-first, iterative workflow.
Autonomy can be a 10x force multiplier. Yeah. It demands human discipline. You need clear prompts, strict cost management, and rigorous code review to avoid getting buried in technical debt, especially with those scary security numbers.
Which brings us to our final provocative thought. There's an old axiom in computer science. Programs are meant to be read by humans, and only incidentally for computers to execute. Now that an AI can write production-grade code in minutes, that whole idea gets turned on its head.
The challenge shifts completely. It's not about generating code anymore. It's about mastering the art of reading and verifying what the machine produced.
Your ability to quickly audit those changes, to understand why the AI made a certain choice, and to critically vet thousands of lines of code, that's the new core skill.
Exactly. Just accepting what it built isn't enough. Your value, your essential human value in this new era, lies in that verification loop and applying your judgment to the machine's output.
Dive deep, verify everything, and we'll see you next time on The Deep Dive.